Hello everyone, I'm Typhoon, and in this lecture we will take our first steps into the exciting world of software-defined radio by building a basic amplitude modulated receiver, AM receiver. Think of it like an AM car radio capable of receiving AM signals and converting them into audio you can listen to. However, instead of working with the live radio signals right away, we will simplify things by using pre-recorded file of captured radio data. This approach lets us focus on learning without needing any hardware just yet. You can download this file from the resources section of this lecture. And at this stage in your STR journey, there are two key areas to focus on. The first is learning how to use GNU Radio Companion, a powerful tool for STR development. And the second is understanding the theory behind how STR works. In this lecture, we will concentrate on the first, getting hands-on with GNU Radio Companion, while we will touch on the radio theory later. The main goal here is to build your practical skills. So if some of the steps feel a bit like following instructions for assembling a model airplane, don't worry, this approach is intentional. As we progress through the few sections, we will revisit this AM receiver project to explore the underlying concepts in greater depth. By the end, you will not only know how to build a receiver, but also why each component works the way it does. For now, let's dive in. We will open a GNU Radio Companion and let's start building your first project. Let's start by creating a new flow graph. You can do this by navigating to File, New, Key to Graphical User Interface, the first one, and that's it. Or you can simply press Ctrl N. This action will open a basic flow graph template with two blocks already present in the workspace. Every new flow graph begins with these two blocks. The option blocks, this blocks contains the fundamental settings and some documentation for your flow graph. And this variable block, this represents a variable named samprate. So if you have worked with programming languages like C or Python, you can think of these blocks as a way to define and manage variables within the flow graph. Specifically, this samprate relates to the sample rate for your project. So think of this as a variable in programming language. While it is not strictly required, it is considered good practice to personalize the option block with some basic information. Now we will change the title. Let's change the title to like my first, or let's AM receiver project, or like AM receiver, and we will update the description. Let's say lecture on AM receiver. Next, we will add a new block to our flow graph. Specifically, we will enter the Q2 graphical user interface entry. We'll drag and drop here, which we will use this shortly. So to locate the new blocks efficiently, you can always press Ctrl F and type the name into the search box. So your flow graph should now look like this here. Let's organize this so it looks nice. Now let's take a closer look at this Q2 graphical user interface entry, a block similar to this variable block. This entry block stores a value that can be used throughout the flow graph. However, there's an important difference. The value in this GUI entry can be modified in real time while the flow graph is running. Now, it is a common practice to group variable blocks and entry blocks together at the top of the flow graph. While this makes your workspace more organized and easier to understand, it is not strictly necessary. So the flow graph will run the same way regardless of where the blocks are placed. To configure this entry block, we'll open it with double clicking on the to open its properties window, and we will change the ID field to frag, and we will set the default value to 880E3, which I will explain this right now. So now let's break this down. The notation 880E3 here is exponential notation, which stands for, let's open a notepad, which stands for 88,000, 880,000. So, or for this, times 10, 3 on the like small side, like this, right? So, the part after this E represents the number of zeros added to the number before it. For example, this here we wrote means is equals to this. Similarly, this equals to exponential notations is widely used because it makes large numbers much easier to read and interpret compared to their expanded form. Also remember this notation, it will come up frequently as you work with GNU Radio Companion. But here's the catch. If you click the apply, you will notice an error message at the bottom of the window. This happens because the default value you've entered isn't valid yet. The error message looks something like this, right? Now let's address this problem. Let's address the problem causing the error. This issue is related to data types. So far, we have learned that how flow graphs can be imagined as numbers flowing from sources through processing blocks and into sinks. However, we haven't yet explored what kinds of numbers these are. In GNU Radio Companion, just like a programming language such as Python, Java, or C++, there are different data types. Each data type determines what kind of numbers a block can work with. Now, take a look at the type property of this entry, GTU graphical user interface entry block on your screen. By the default, the type is set to integer, meaning the block can handle whole numbers like both positive to negative, like 65. Oops. Yeah, like 65, 700, like 100,000, right? 100,000. Or like positive, negative numbers like 60 minus 65, like 500 or 5,000, like this. Now, this is where the usually arises. So the default value we entered earlier, this uses exponential notation, which creates a floating point value. The floating point numbers include decimal points and look like this. For example, p, right? Or minus 8.9. Since an integer type block doesn't accept floating point numbers, the mismatch triggers an error. And now we'll open this pull down menu in this type properties, and we will change the setting from integer to float, and then click apply. This adjustments ensures that the blocks can accept the floating point value we have provided, and the error will disappear. And here you will notice that the appearance of the block in the workspace has updated to reflect the value you've entered. This feature is incredibly helpful as it allows you to quickly understand the configuration of your flow graph at a glance, even as it becomes more complex over time. Now let's add another key to a GUI entry block with a different ID and a default value. Instead of creating it from scratch, we can save time by copying and pasting the existing block. The newly created block will appear in this workspace with this ID set to frag underscore 0 by default. So we will double click on the block to open its properties. We will change the ID to center frag, and we will change the default value to 900A3 and click apply. Because this block was copied, the type here is already set to float. So there's no need to adjust that setting again. Once you are done, your flow graph should look like this. While this isn't required, it is a helpful practice to keep all variable and entry blocks grouped together at the top of the flow graph. This organization makes your workspace easier to navigate as your project grows in complexity.